All right. We'll give you all a few seconds to get on some more. Now, the way this is going to work today is that I will be showing you some stuff we found in today's tide pools. And then teachers, if you want to go in, if your class has any questions, you can type those questions into the chat. And I'll do a break every few minutes to make sure that I answer those questions from the chat. I will say we have a ton of participants today. This is our biggest tide pool live stream yet. So if we don't get to all the questions today, don't worry. I will be typing up answers to them and sending them back to you all teachers and your classes later. So if I don't get to your question today, I promise your answer will come very soon, and I will try to my best to answer all the questions that you have today. So I think with that being said, we can go ahead and get started. Again, thank you all for coming. My name is Veronica, and I work at an organization here in Santa Barbara called Explore Ecology. And we go around to different schools all over the county and teach lessons on water quality, waste reduction, energy. We do field trips, and today we are doing a virtual tide pooling lesson. So right now you are here with me at Coal Oil Point, and this is located in Goleta. It's actually just north of UCSB. You'll see behind me, you may see UC Santa Barbara behind me. There's also some classes that are even out here today exploring the tide pools as well. So this is a really special place and a really great place to explore the intertidal zone. There's a ton of life here. One other really cool thing about today is that today through Sunday is actually an event we call the King Tides. So that means that the Earth is lining up with the moon and the sun, and so our tides are really, really high when they're high, and they're really, really low when they're low. So this means that we have a chance to see a lot of super cool stuff. So we're gonna get started, and I can't say that the best teacher in the tide pools is me. I think the best teacher to help you learn about the tide pools are these critters that we have behind us. So I'm going to point a few different ones out to you. We've got our California mussels. Here, I'll actually come on this side, and I'm being really careful where I'm stepping because you might see there's a lot of tiny little anemone beneath me. But these blue things here are our California mussels. Then you might see these white little ones sticking out here. Those are barnacles. And then all these little dots you see along here, those are aggregating anemone. So I want to talk a little bit about what life in the tide pools is like for these guys, because life in the tide pools is really, really harsh, right? Especially during low tide. All of these animals are marine organisms, meaning they like to be in the water, but during low tide they're fully exposed, and so they have to have a lot of protections because there are a lot of factors working against them. So there's two types of environmental factors when we're thinking about life in the tide pool. There are abiotic factors and biotic factors. So bio means life. Biotic factors usually mean maybe some predators coming to want to eat them, right? Other organisms taking up space. Abiotic factors are factors that don't have to do necessarily with life, so that could be the water level or the amount of sun that's out, how hot it is, or even how windy it is. All of those biotic and abiotic factors are really affecting how all of these little critters live. So the first one I'm going to point out is our California mussel. So that's these blue ones right here. You can see they're closed right now, right? None of these critters are open when there's a low tide because they need water to survive. So what these mussels do is they actually close up when there's still water covering them, and that way they keep water inside so they can breathe. You might also notice when you look at a mussel that they're really firmly attached to the rock. That's because they secrete something out of a gland called a basal thread. And those basal threads are super duper strong. One basal thread that's holding a mussel to that rock can actually hold a whole quart of milk. right? Something so small is very strong, and so they are really firmly attached to that rock. There's actually scientists here at UCSB studying those bisel threads and trying to bioengineer them, right? So trying to engineer them and turning them into other fibers. I'm actually going to show you also what a mussel might look like a little bit closer up. I've got one right here. So you can look at this. So this is a really big California mussel. You might notice, see all those growth lines, right? They grow as they get bigger. And these are bivalves, meaning they have two valves, right, in and out. And when they're shut, they'll shut like this. Obviously this one doesn't have anything in it. You might also notice that they're really shiny on the inside, right? All of these shells that we see will have this mother of pearl on the inside. That's what we call it. And that's that really shiny surface. And we actually use that for a lot of cool like rings and jewelry, that sort of stuff, which is pretty amazing. All right, I'm going to put this mussel back down. All right, next I'm gonna move to, right now you can tell they are closed, but when they're underwater and when it's feeding time, they'll actually open up and send out these really feathery legs to come and grab their food, which looks really crazy. If you want to watch a video of a barnacle opening up and seeing its legs, you should look it up. It's super crazy looking. Now, the last thing I want to talk about on this rock is our aggregating anemones. You might notice all those little tiny pieces of shell down there. A lot of those are covering up the aggregating anemones. That's how we know, is that they cover themselves in these shells for protection, which is super, super cool because you can see they're a little squishy. I can squish them, but they use those shells as camouflage and as protection from anything like a bird that's coming around and trying to eat them. Now, when they're open, they might look a little something like this. If you can see it, you might just see the little green ring, and the green is what I really want to focus on because these anemone have a symbiotic relationship with a type of microalgae. An algae is neither a plant nor an animal. It's kind of somewhere in between. And so that is what makes those aggregating anemones look green, is that algae, which is super cool. The algae give the anemone energy, and then the anemone puts them out in the sun so that they can do photosynthesis and continue to grow. Really, really amazing, cool stuff. So these are just a few of the teachers of our life in the intertidal, our California mussels, our barnacles, and our anemones. Do we have any questions so far? All right, it's not looking like there's any questions yet, so that is fine. And remember, as we go, feel free to type questions into the chat. Every few critters we look at, I will ask her some questions and I can answer those. So we're gonna move on to another group of critters that we find a lot in the intertidal. And when you find them, you might actually just find their shells, because a lot of these critters actually exist a bit further out, but when they pass away or they lose their shell, that's what gets brought up here. And those are sea snails. We have a ton of different sea snails here in California. Now, the first one I want to point out is a Kellett's whelk. So Kellett's whelk are super cool. They are a sea snail, and they don't actually normally live in the intertidal, but a lot of their shells will wash up into the intertidal once they have passed away, right? And so Kellett's whelk are super cool. They can grow up to about 7 inches in length, so a bit longer than this one, right? And we don't actually know very much about their life cycle, but what we do know is that they reach maturity around 20 years old, like some people I know. And that means that they actually must live a lot longer than that, right? If they're only reaching maturity at 20 years old. So pretty cool critters. And when you actually see the whelk or the snail that's in here, it's got a really colorful foot. And so I do want to say that if you find any shells like this or any shells in the intertidal, if you want to take them out, I really suggest that you touch them very lightly, because if there is still a snail attached, you're not going to be able to pull it off, and you don't want to force a shell off that's not going to come off, because that could really hurt the critter that's inside. Luckily this one I knew was empty, and so I pulled it off. And it's even actually got a tiny little limpet. That's another type of sea snail right here. Limpets are super duper cool. They're like the farmers of the intertidal. So what limpets do actually is they might find a patch of rock. Oh, that's some deep sand. They might find a patch of rock like that, and what they do is they keep it clear of any other critters. So they actually go around and they farm the algae that grows there. They raise it down, they eat the algae, and then they keep it clear so that algae can grow back, and then they'll eat it and they'll wait for it to grow back. They're tiny, tiny little grazers. I like to think of them as if cows were super small and also somehow snails. Now, I've heard that we may have a few questions in the chat, so I can answer those.
What do anemones and also mussels eat?
Good question. What do anemones and mussels eat? Well, anemones can eat a variety of things. It kind of depends on their size and the type of anemone, right? They can eat small stuff like plankton, that's little things floating around in the ocean that can't move against the current. They can even eat crabs, and some anemone that are big, that have really powerful stinging cells, will actually eat small fish as well. So they eat a wide variety of things. Now, mussels are what we call filter feeders. And so filter feeders will filter through the water column, taking little plankton and other little things out as they're filtering. If anybody's seen that episode of SpongeBob where he filter feeds and he goes and he's taking in the water, that's pretty much what mussels do. You might notice a lot of SpongeBob references today because a lot of the SpongeBob critters are also part of the intertidal, which is pretty cool. Do we have any other questions?
Yeah, how long does the low tide last?
How long does the low tide last? That's a really good question. It really just depends on the day, right? So right now, because of king tides, this tide is out super, super far, and so it'll probably be low for a few hours. On days where we don't have a super low tide, that can be a lot shorter, right? Only about an hour that it's low. Yeah. All right, there's one more.
What are mussels doing to the rock?
What are mussels doing to the rock? Well, they're not really doing anything to the rock. They're just attached to it, right? So they're not actually necessarily carving out the rock actively. They are just attached through it through that bisel thread, that really strong thread that they put down there. And sort of similarly with barnacles. Barnacles don't have a bisel thread, but they attach themselves through this cement that they make. So both of them are attached to the rock, but they're not like actively eating or boring through the rock. Over time, they might leave some indentations, but that's about it. All right, we are gonna keep going because I have some other snails that I wanna show you. So, oh, wow, I got a little attached. Here's another one. This is a wavy turban snail. And so it's named after a turban, which is a cultural type of headpiece, and it sort of wraps around and is a little pointy, and so it kind of looks like that. And so wavy turban snails live around here as well. They are also super cool. You can often find these in the intertidal, and you'll see they have that waviness on the sides. They're super pointy, and they often, like you're seeing here, have some stuff growing on the top. So you can see that some algae has actually attached itself to this wavy turban snail and is growing off of it. I also want to point out the inside again. Look at that gorgeous shine, right? Very similar to the mussel that we saw. It has that really pretty mother of pearl shine on the inside, right? And once again, I checked to make sure that there was nothing living in this. You can tell on the inside, there's no critter in there. If there were a critter in there, I would not have picked it up. All right, here's another one. We've got a bunch in this little area. All right, this is a type of cowrie, which is another snail. And you can see, I think it's an almond cowrie. It's got, or chestnut cowrie, it's named after a nut. It's got this very cool brown print, right, on its side, or coloring. And you can see the bottom, it's got a bit smaller of an indentation than the other ones, but the snail would come out of here and have the foot, and it would just crawl around the intertidal. So really, really cool. We really like sea snails over here in this intertidal zone. Amazing. So we actually have, let me think, one more that I kind of want to show you. It's not a sea snail. It's more like a sea slug. So you're going to follow me because I found a really cool critter, and there's actually a ton of them out today. So come on over here. I'm going to very gently take it off. Come on out. Oh, there we go. There we are. This is a California sea hare. So cool. I'm going to move into the sun so you can see her a little better. I said her, but she's not really a girl. Now, a cool thing about sea hares is that they are what we call hermaphroditic, meaning they are neither female or male. They just sort of decide when the time comes along to reproduce what they need to be. Now, they are named sea hares after these fun little things they've got on their head that look like little ears of a hare or a rabbit. But in actuality, that is a lot more like a nose sensory organ that they move around. Now, there's one more thing on the bottom. You can't really see it. Can't really see it on this one. Or actually, whoop, it's up here. Here it is. They have this vestigial shell. So this shell is something that's left over from when they lived in shells, but now that they don't, they just have that little bit left. Kind of like you and I have an appendix, which is vestigial, meaning it's something we adapted a long time ago, but we no longer use. They have that as well, and it's that little shell. Now, they can weigh up to 30 pounds. This one is only about a pound in my hand, and it's so heavy, but they can actually weigh even more than that. And although they are super cool and they can get really big, up to 3.5 feet long, they actually only live about a year, and they reach maturity in about 7 months. So pretty cool, huh? I love sea hares, and we found a ton of them today. Now, I am going to tell you, if you find a sea hare out in the tide pools, unless you're like me and you know how to pick them up, please leave them where they are, because they much prefer to be in a tide pool. If you see one, you can very gently give it a pet, but I would normally leave it where it is. And this one, I'm actually going to put back in some really cold water in the shade so that it is comfortable. So I'm going to walk around, and you're going to see me walk around. And I'm putting it over here in the shade. My pants are getting a little wet. That's okay. There we go. Very nice. Okay. Pretty cool. That was my favorite part of today, for sure. So, now it's time for some questions. Do we have any questions from you guys? I'm all slimy from that sea hare.
We definitely do have some questions.
Amazing.
I've got a good one. How do the animals stay alive when they are so deep inside the shell?
That is a really good question. Well, think of it kind of like a little den for them, right? It's not like they're hibernating because they're not staying asleep in there for a really long time, but they're actually able to filter through water that they get oxygen out of to breathe, and they come out when they need to feed. But because they live in the intertidal, they are adapted, meaning over time they've gotten these traits that help them to survive. So they're well adapted to be closed up for quite a long period of time. That being said, when we get really king tides, especially like in the summer when it's hot, or today, it's actually quite warm for November, right? Sometimes we can see really big die-offs of intertidal marine life because they might not be used to being out and exposed for that long. So that's a really good question. Do we have any other questions? Yeah?
How do the snails support the weight of their shell?
How do snails support the weight of their shell? Well, the snails are actually a lot bigger than you think, right? The snail is filling up that entire shell and then some. So they're pretty able to support it. Also, when you think about snails, they're not really floating around in the tide pools or swimming like a fish would. They're just sort of crawling along. And so because they're crawling along, then that means that, you know, they don't have too much weight. Also think about when you're underwater. I know when I'm underwater, I can pick people up that I might not be able to pick up when I'm not underwater, because gravity is just different underwater, and so you actually are able to support more.
I have another one about mussels.
Yeah?
Someone's asking, how big can they get?
How big can they get? That's a really good question. Well, I showed you that pretty big one, right? Mussels can get about that big, but in some parts of the world, they find really, really big mussels. I'm gonna say that California mussels, you know, max out sort of around that big. They reach full size after about 3 years of living, but we don't technically know how long they live because we keep finding some that are older and older and older, which is pretty cool.
I have a couple more really good questions.
Okay, I think we'll take one more and then we'll keep doing some more stuff.
Last one. What would happen if all the mussels disappeared?
What would happen if all the mussels disappeared? That's a really good question. If all the mussels disappeared, that would be a really big problem for the intertidal, because the way environments act, right, we need everything existing to keep everything working well, right? If we take out one species, that has ripple effects for everything else down the line, right? If we didn't have mussels, then that might leave barnacles to dominate more space, which would not be great, right? Or limpets to dominate more space. But even with mussels, we don't want too many of them. So I'm actually going to talk about a critter that limits how many mussels grow, and that is the sea star. Now, I'm showing you this dried up dead sea star because the real sea stars that we have here in the intertidal, they didn't really want to come off today, so that's okay. But they eat mussels. Sea stars are really good at eating mussels, and they actually keep the tide pool in balance, because if they weren't there eating off some of the mussels, then there would be too many mussels growing. That wouldn't leave enough space for other things in the intertidal, and that would just throw the whole balance off. Now, sea stars are super cool because you see this hole down here, right? Sea stars do not have feet. Instead, or sorry, not feet, excuse me, teeth. Instead, they have this little mouth, and what they do, instead of like you or me chomping down on our food, they actually push their stomach out through their mouth and eat their prey, engulf their prey. And so sea stars might not look like it because they're so cute. They are really vicious predators, and they are some of the top predators of the intertidal system. They also can move around. It doesn't seem like it, right? They seem so rigid. But if you've ever seen a video of a sea star sort of moving around, because they do move around, they have what we call tube feet on the bottom, which are kind of like suction cups that suction it and move it along, right? So pretty cool. Sea stars are pretty cool. All right. Now, there's one final sea snail that I do want to focus on, because this one is super cool and really important in California history. So I'm going to put the sea star back, and I'm going to pick up something special. Now, I do want to say we didn't find this one today because these are really hard to find, and this is a big one. But this is one that we have, and this is an abalone shell. Look at how stunning that is. Look at that mother of pearl on the inside. It's got a really unique rainbow shine, right? Super cool. And here's the outside of this abalone. And abalone are really important. This is a red abalone. And for a long time, abalone were one of the biggest exports for California. They were a really big harvest here. There were so many growing off of our coast, and we would harvest them and eat them. Abalone was really common to be eaten. But the thing is, as the abalone industry boomed and abalone fishing kept happening, they actually experienced a really big population decline in the 1970s due to over-harvesting and overfishing. And so that ended up with the abalone becoming really, really rare, right? Really hard to find because we were harvesting so many of them. We were harvesting them not only for food, but also because of this really, really gorgeous inside. I'm actually wearing, and I wore this just for today, an abalone ring. And you can see, you might be able to see that shininess, very similar to the abalone on the inside. And so it was also harvested for things like jewelry as well, right? Now, abalone was used for a very long time and continues to be used by local native tribes, right, like the Chumash. But the thing is, they did a really good job of harvesting just enough and not too much. And so that's why we didn't see such a population decline when, for a long time, it was just the Chumash living here. But once a lot of other people moved here and the harvesting of abalone went up in the 1900s, unfortunately, that's when we saw dangerous overfishing and we ended up with a really low population. And now you actually cannot harvest abalone, especially here in Santa Barbara. So this is a protected species. All right, do we have any questions? Oh, I keep getting stuck on that.
We've got lots of questions.
Okay, amazing.
I think I'll focus on the abalone ones right now just because we were just talking about it. But does abalone stay shiny forever?
Good question. That inside of that shell, yes, that will stay shiny. But of course, when the abalone actual snail is inside of that, you're not going to see the inside of the snail, of the shell, right? You're just going to see this outside, which can be a little shiny, but is usually pretty rough and inconspicuous.
How big can abalone get?
How big can abalone get? Well, this is a super big one. I don't know exactly just how large abalone can get, but I know that this is an example of quite a large one. So this is probably on the higher end of how large abalone get.
And I have a fun one too.
Yeah?
Do you know if these creatures sleep as much as us, or maybe more than us?
That's a really good question. Generally, sort of a good rule of thumb for any wild critter is that they probably sleep a lot less than us, right? Because they have so many biotic and abiotic factors affecting them, right? They're always making sure that they're not getting eaten. Then that means that, you know, they're probably not sleeping as much as we are. Yeah. Any other questions so far?
How about how fast do sea stars move, and do you know how far?
Well, really good question. I have to say I don't know the exact answer to how fast they move. I know they can move quite far in a few hours. They can cover quite a large range, but I will definitely have to look up more on that and get back to you. Amazing. Okay, so now I want to show a few more things. Some critters that are pretty important to the intertidal as well, although they may not live here full time. I'm going to have Josh follow me, and we're going to point this way, actually, because I just want you to a little bit see what is behind me. So you can see that there is a lot of the intertidal going on behind me, and you might even see some birds out there. I want to quickly focus on the birds out there because they are a really important player in this area too. Now, one of the birds that you might see over there, it's white, it just shook its head all around. It's right over there. That bird is called a great egret. And great egrets are super cool birds. They're really common in the intertidal zone, especially here in California. And they are one of those big predators. right? Josh, are we seeing the egret? Amazing. Okay, I'm gonna come up and I'm gonna show you a little closer what egret looks like, right? So this is the skull of an egret. Now, this is the skull of a snowy egret, but still an egret. It's just a smaller type, right? And you can see they have this keratin sheath on their beak, on their nose. That's what gives it that color. And then you can see they have really, really light features. Now, birds' skulls or bones in general are super duper light because they have to fly, right? And so they are super light in moving around, and their bones are really light. All right, cool. I just got an update that sea stars can actually move 5 to 10 feet in a minute. That's actually so much faster than I thought. Pretty cool, amazing. Okay, so now I want to focus on something perhaps not as fun as everything we've just been looking at, because the intertidal does not exist by itself, right? People live on this land, and so because people live on this land, there's going to be consequences for actions we have. These are 2 pieces of marine debris that we found today while exploring the intertidal. And actually, both of these are made of the same material. They are made of plastic. And plastic is one of the worst types of marine debris, if not the worst type of marine debris that we can find. Now, marine debris is just a fancy word for ocean trash. And this just looks to be a piece of fiberglass. So this is probably from a boat. And you can see it's green, it's colorful. It's always not great when plastic is colorful or small, because then it means it looks a lot like food, right? Now, this other piece took Shayna and I about 15 minutes to undo from some mussels. We were walking along right there behind me, and we saw this and we thought, oh, it's just seagrass. And we looked closer. This is actually all plastic fishing line wrapped up with some kelp and some seagrass, some eelgrass. And so this is a really big problem. It was wrapped up in a lot of mussels, very stuck. And also some of the mussels already had it inside trying to eat it, right? And so this is a really big problem. Now, Coal Oil Point and pretty much any part of the coastline in Santa Barbara County is at the end of a watershed. You might have heard the term watershed before, but it's really important that we go over it, right? So I want you to think A, water, B, shed. And when you're thinking of shedding, I want you to think of like a dog shedding its fur, right? And so a watershed is an area of land like we're on right now, and like you're on at school, or if you go home. It's an area of land where all the water, when it rains, is draining down to one spot. So if you're standing on land, you are in a watershed. And that means if you leave trash on the land, that's gonna move down through the watershed until it reaches the end. And here on the coast, we are at the end of many different watersheds. And that means that a lot of this trash washes through the creeks, through the town, and all the way here. Even if you're not anywhere near the ocean, if you drop a piece of trash and it gets into a stream or lake or river, it can most definitely make it out here. And so after storms, we find a lot of this marine debris. So it's really important that we're keeping our watersheds clean, right? That's really important because we just want to keep it clean, not only for ourselves so we can enjoy this area, but for all of those critters that I just showed to you. It's really important that their area that they are living in is clean, right? Not just from things like plastic, but from chemicals like oil or fertilizer or bug killer, right? We want to try and limit our use of any of those things, or make sure that we're using them properly. Now, do we have any other questions?
I have a question about egrets.
Yeah.
Do you know if an egret gets hit by a wave, do you think it can stay standing or do you think it might fall?
That's a really good question. Depends on the size of the wave, right? Because they are so light and nimble, they will definitely sort themselves out if they need to. But obviously, when big waves come along, they can usually tell, and you'll see them kind of hop up over or fly to a different spot. Yeah. Any other questions? Okay.
Do you know if there are a lot of predators that may want to eat sea hares, sea snails, any of the animals you talked about today?
I can say there are definitely a lot of predators that want to eat those, and those predators are sort of lurking around in the tide pools around us. Things like seagulls, even hawks. I've actually seen quite a few hawks in this area, right? All those big birds want to eat up that stuff, right? Okay, now I'm going to pause on the questions, and I want to talk about one more thing in this area, and that is what this area is. So right now we are standing in a marine protected area, or an MPA. And marine protected areas are designations of places like this that are made by the government. And marine protected areas have different levels. Some marine protected areas are okay to fish in, they're okay to take stuff in, you can swim, right? We're just protecting it from things like big ships or drilling. But other marine protected areas, actually like Coal Oil Point here, are no-take zones. So everything that I just showed you, we're not taking any of it back with us. Even if there's a cool shell, even if there's a cool critter, we can't take any of it. People also are not allowed to fish here. You might see some people surfing behind me. Surfing is fine, right? That's totally okay. It's not hurting the tide pools or any of the critters, but we can't take anything. Now, there's another thing that I do want to point out, and this is something that a lot of marine protected areas are trying to protect against. So I'm going to have Josh actually kind of lift up the camera and follow me over here. You get in a different angle of the tide pools. Amazing. So, you might see that big thing behind me, that big machine out there. That is an oil rig, and that one is actually called Holly. That's platform Holly. And when you are down in this area, you might notice a lot of those oil rigs. So something about Santa Barbara is that we have one of the largest natural tar seeps, meaning oil is actually coming out of the seafloor on the west coast. And although that is great, and for a long time many people have used that tar for building, unfortunately in the 50s or 60s we started wanting to extract or take out a lot of that oil, and that is what those oil platforms are made for. Now that one is actually out of commission. It's not working anymore. But once we build those big things, it's difficult to take them down. It's kind of turned into a home for a lot of critters underneath there, and so it's a big area of debate. But a lot of what marine protected areas are trying to do is protect areas like this, gorgeous areas that are so important for our wildlife, against things like future drilling in the area. Now, something really cool that you also may be aware of, because it affects your area of the coast as well, is that basically all the way from down here and all the way up to just under Morro Rock, up to about Pismo, has just been designated under the Chumash Heritage National Marine Sanctuary. So it's kind of part of an MPA, although that area is not necessarily a no-take zone. People can still fish. People can still take stuff, but it's just a step towards protecting that area for the future to make sure that we're not going to extract more stuff from it, right? We want to make sure that what happened to the abalone doesn't happen again. Do we have any more questions? Maybe any about MPAs or anything like that? We can also talk about critters.
I'll talk about critters in a second, but I do have a good question. Are some of the chemicals in sunscreen and maybe leave-in conditioners harming sea life also?
That's a really good question. Yes, That's true. A lot of the chemicals in many of the things that we use every day on our body, especially sunscreen and especially hair stuff, are harming or can harm the critters in the intertidal, right? And can contribute to the lowering health of our oceans. So I always suggest people try to buy things that are just mineral based or maybe more natural and don't have as many of those synthetic chemicals in it. I know the sunscreen I use today, because I layered up on sunscreen, is mineral sunscreen. Sometimes it can leave you kind of white, but it's still helpful and it helps our critters around here.
What effects would the plastic have on fish if they ate it?
Really good question. So plastic would not be good for fish, not so much because it has any chemicals it's leaching out, because not so much that, more that when these animals eat the plastic, it goes into their tummy, and although we have really big stomachs and we can pass through some solid things, they cannot. And so basically what happens is that plastic builds up in their digestive system, it makes them feel like they're full, then they stop eating, and unfortunately then they die. Yeah. Any other questions?
I have one more interesting one.
Yeah.
Someone's asking, are any of the animals that you showed us today dangerous for us at all?
Good question. None of the animals I showed you today are dangerous for you. I know one thing that could be potentially a little dangerous is crabs because of those pinchers. If there's like a little tiny hermit crab, that's not so much a problem, but bigger crabs, if they're really pinchy, definitely don't want you to touch them, right? Because that could be a big problem. Now, anemones also have stinging cells, but because we are so big, we don't really feel that sting. It feels a lot more like kind of sticky. If you touch an open anemone, it feels a little sticky. So I wouldn't say any of them are dangerous, right? But I still want you to be super careful when you're exploring the tide pools. Any other questions? I'm going to do a little bit of a time check. We've got about 2 minutes left. I think I can answer one more question.
Okay, fun. How about the last question just is, do you know what the egret's main predator is?
The egret's main predator. I would say the egret's main predator is other birds of prey, right? That could be a hawk, that could be an osprey. Think of an osprey like a marine hawk. They're basically same size as a hawk, sometimes a little bigger, and they love to eat little fish and other birds, right? It could also potentially be if they're in the water, like a shark or something, but that's not as common. All right. I want to thank you all for participating today. This was such an amazing, terrific tide pools. This was terrific tide pools. And I know that there are probably quite a few questions that I did not get to, but no worries. I will type up the answers to those and I will send them straight to you. So I want to say thank you so much for joining us today. I hope you learned a lot about these critters and the issues affecting them. And I hope you feel empowered to protect the tide pools by making sure you're being safe in the tide pools, being safe with the critters, and making sure you're not leaving behind any trash and picking up any trash that you see. So thank you so much for joining us, and we will hopefully see you in your classroom soon, potentially for some in-person lessons. Have a great rest of your day. Are we done? We're ending the live, but I'll stand here until then. Ooh! Did you see all those birds just come by? That was pretty cool. A lot of those were seagulls, but some of them were pelicans.